Assalamu alaikum wa rahmatullahi wa barakatuhu, and a very good morning to all of my dear students. Look at this. In this video, we will discuss about the work done, and today's topic is work done in a half trip. Half trip. Look at this. In the previous video, we have discussed that work done, we have measured the work done if a body is moving in a circular path. Okay, and we know in circular path the displacement, that is s equal to 0. If s equal to 0, then if you put here a value of s equal to 0, then f and cos theta, this work done will be 0 also. Okay, that if displacement is 0, if any quantity, either f is 0, the work done is 0. If s is 0, work done is 0. Or if cos theta is 0, work done is 0. Or if theta equal to 90 degree, that is f and s, work done, f and s both are perpendicular, then theta equal to 90 degree, then cos theta equal to 0, then work done is 0. Okay, so these are the conditions we have discussed. Then what will happen if a body is moving in a circular path but cover a half distance? Like here, this is the sun, look at this is the sun, and the earth is moving around the sun. But if it move here from here to here, then the displacement is 0. Okay, then we know that if the displacement is 0, means work done is 0. Then what will happen if the body is, if the earth rotates half, or a half trip? Initial point is here and the final point is here, so cover a distance only this much, then we didn't say that work done is displacement is, here is some displacement, this displacement here. Okay, look at this, how much displacement it is. If a body is moving from here to here, then covers this distance, then this is the distance, shortest distance. This is the initial point A and final point B, so shortest distance is this one, so there is a displacement. Okay, now look at this. In half trip, or at any point, if a body is moving in a circular path, okay, then what will happen? Where is the force and where is the displacement? In what is the direction of the force and what is the direction of the displacement? Look at this. Here if a body here, for example, the earth is here, if the body will move, if the earth is at that position, in that position the direction of the force is always in that direction, towards the center. Okay, towards the center, because this sun is attracts the earth towards the center. That is, this force is called gravitational force of the sun, and it is always acts along the radius. Any body is moving in a circular path, this body is moving in a circular path, then the direction of the force is always towards the radius. This is called the centripetal force that we have discussed in the chapter number 1. Okay, and here the centripetal force is the force of gravity. Okay, so the direction of the force along the radius, so this is the direction of the force, and at that point the direction of the displacement is that side. Okay, now look at this. At any point the direction of the displacement, here at that point, the direction of the displacement in that direction and the force is that direction. At this point, the direction of the displacement in that direction and the force in that direction. Okay, now look at this. This is the direction of the force and this is the direction of the displacement. Look at the angle between F and S is 90 degree. At any point, if you calculate each and every point, here the direction of the force is that direction, and the direction of the direction of the displacement is in that direction, and the force is that direction. So the angle between in each and every point is 90 degree. Here 90 degree, here 90 degree. If the body will move here, the earth is rotated from that point, then the direction of the force, as I said, direction of the displacement is that direction, and that force is along the radius in that direction. So each and every point the theta will be 90, and if the theta will be 90, we know cos 90 equal to value is 0, and cos 90 value is 0, then put the value fs cos 90, that is fs 0, then the work done is 0, no work done. Okay, if a body is moving in a circular path, at each point force and displacement F is perpendicular to S, that is displacement, both are perpendicular, that is there makes an angle theta, and cos theta equal to 0, then there is a no work done. Clear? The same example is here. A coolie carrying a load on his head. Okay, coolie carrying a load on his head. Look at this. This is a coolie. Okay, he is carrying a load. This is load carrying and moving in that direction. So the direction of the coolie is in that direction here, and the force of this load, the direction of the force of this load is in that direction. Okay, so look at this here. Due to the gravity, the force is in that direction, and the body is moving, the coolie is moving in that direction. Look at this here, S and F. So the angle between F and S is also 90 degree. Look at this. The body will moving, the coolie is moving in that direction, and the force is working as that direction. Why? Because due to the gravity, gravity, okay, gravitational force. So the F and S, there is a 90 degree. So 90 degree means cos 90 value 0. The work done is no work done. Look at this here. Displacement of the coolie is that direction, and force is in that direction. Okay, so the coolie carrying a load on his head, he is not doing any work according to physics. According to physics, he is not doing any work. Why? Because the displacement and the force, the direction of the displacement and the direction of the force makes an angle 90 degree, and if he makes an angle 90 degree, then cos 90 equal to 0, and there is a no work done. Clear? Hope you have understood. Now case number 4. Case number 4 is that if F and S works oppositely, or the direction of the force and displacement is opposite direction. Here look at this. If the force is applied here, but displacement is in that direction, so force and displacement F and S work in opposite direction, both are in opposite, then the angle between these two is 180 degree, and we know that cos 180 is equal to -1, is -1. Here one more example. Here the force is in that direction and the displacement is in upward direction, then the angle between these two is 180 degree. Okay, force and displacement, the direction of the force and displacement is opposite to each other, so they makes an angle theta. What is the condition? There is a two condition, that is the force of the friction. If a body is moving, okay, if a body is moving in that direction, then the force will act opposite direction. The frictional force acts in opposite directions. If a body is moving, frictional force always acts against the motion of the body. Okay, then the displacement of the body is that direction, then the force will act that direction. So they makes an angle 180, theta equal to 180, then the cos theta equal to -1. And if you Second condition is when a ball or a body thrown upward, then the body will move upward, but their force will be in opposite direction. Okay, here the body is at the point A. Look at this. Here this is a ball at the point A. If you move, body is moving from A to B, the direction of the displacement, the body will move from A to B, then there is a displacement, so displacement will be in that direction, but at that point force acts in opposite direction. Okay, the gravity is also attracting toward the center of the earth, so the force, the direction of the body, that is displacement, is upward direction, and the force acting on the body is downward direction. So in this condition the S and F work in opposite direction. The direction of the S and F, displacement and force, is opposite, that is they makes an angle 180. Okay, and we know cos 180 equal to minus 1. So putting the formula Fs cos theta, here theta equal to 180, and cos 80 equal to minus 1, so we get W equal to minus Fs. So this is called negative work done. This is the condition for the negative work done. Okay, they will ask that write the condition for the negative work done and give 2 example. This is the 2 example. Okay, the number 1, the force of friction, and number 2, when the ball thrown vertically upward. Okay, clear? Hope you have understood. We have discussed the 4 condition. Number 1 that is F and S, they makes an angle theta, so formula will be Fs cos theta, number 1. Okay, number 2, both the body, the force and displacement, both are in the same direction. In that condition theta equal to 0, then the formula will be W equal to F into S. This is the second condition. Third condition that the force and displacement makes an angle 90 degree, then cos 90 equal to 0, then the work done will be F into S, cos 90, that is 0, then work done will be 0, that is no work done, and this one is called the negative work done. This total W equal to minus Fs, that is, this is called negative work done. Okay, hope you have understood. If you have any kind of question, then you can ask write in a comment. Inshallah, I will explain you. Okay, and this one is a very, very important. This one, half trip and the coolie. Many times in ICSC exam, they will ask that cooling carrying a load on his head. Okay, how much work he's done, or is he doing any work? Explain. Clear? Hope you have understood. Thank you.